Good morning, children. Today we are going to start with a new topic that in a book is given by the name area, or in some books it is mentioned by the name area theorem. Now in this chapter there are 7 theorems that are given to you, and you are supposed to understand and learn those theorems and apply them in questions where you have to find out the area by using these theorems. So quickly we are going to start with the very first theorem. I've mentioned over here some important theorems and their results, their outcomes. So the very first theorem says parallelograms on the same base and between the same parallel lines are equal in area. Children, this statement means that if you have two parallelograms which are sharing a common base and the two parallelograms are between the same parallel lines, then the area will be equal. As you can see over here in the figure I've shown you, there is one parallelogram with a black color and name A, B, C and D. And there's one more parallelogram with a blue color that is by the name A, B, C dash and D dash. Now one thing you are going to find over here is that both the parallelograms, the first one A, B, C, D, is having the base AB, and the second parallelogram A, B, C dash and D dash is also having the same base AB. So one condition is fulfilled as per to the theorem. The second thing is this, that the first parallelogram A, B, C, D is lying between the two parallel lines AB and CD. And in the same way, the second parallelogram A, B, C dash and D dash is also lying between the same parallel lines AB and CD. So as per to the theorem, the area of the parallelogram ABCD will be equal to the area of the parallelogram ABC dash D dash. In the same way, children, there is another theorem. And the second theorem is the area of the parallelogram and the area of the rectangle on the same base and between the same parallel lines are equal. Now the meaning of this particular statement in the second theorem is that, say for example, if there is a parallelogram by the name A, B, C, D, which you can see I've drawn with black, and there is a rectangle also which I've drawn with blue, that is A, B, C dash and D dash. So one interesting thing that you are going to find that in both the quadrilaterals, in the parallelogram A, B, C, D and in the rectangle A, B, C dash, D dash, the base AB is common, it's the same. And one more thing, that is the parallelogram ABCD is lying between the parallel lines AB and CD. The same is with the rectangle. The rectangle AB, C dash and D dash is also lying between the same parallel lines AB and CD. So this thing proves by the theorem that area of the parallelogram ABCD will be equal to area of the rectangle which is on the same base and between the same parallel lines AB, C dash and D dash.